All right, here we go. Linear application number 2. This one's about Grandma McGregor's cookies. So, if we read the story here, Grandma McGregor loves to bake her grandson cookies and brownies. On a Sunday afternoon, Grandma McGregor finished baking a batch of delicious cookies and then shut off the oven. And she left the oven door open so it would cool down faster and also warm up the house. So, all of that's just setting up the story. The next part is where we get the information that we're going to use. It says 10 minutes after turning off the oven, the temperature has dropped to 300 degrees. And 14 minutes after turning the oven off, the temperature has fallen to 250 degrees. The temperature of the oven varies linearly with the amount of time that has passed. So that means that the temperature is dropping the same amount every minute. It's not dropping more or less at any particular time. Okay, so we need to come up with a couple of points, and if we look at the first one, 10 minutes. After 10 minutes, the oven has dropped to 300 degrees, and after 14 minutes, the oven has fallen to 250 degrees. So we're going to make 2 points that are going to look like this: 10, 300, and 14, 250. Okay? Now, what I would strongly encourage you to do as we're going through this problem, we've already done the first part together, but what I would strongly encourage you to do is pause the video before I do the next thing and see if you can do it on your own. And then turn the video back on and see if you were right. Okay, or correct whatever mistakes you might have made. Okay, so now would be a good time to pause the video and think about, what does X represent and what does Y represent? Okay, so if you look at our coordinates or our points, the 10 and the 14 are the X values, and the 10 and the 14 are minutes. So the X coordinate represents minutes, and the Y coordinate is 300 and 250, which is temperature in degrees. So we would say the Y coordinate represents degrees. Okay, so now you could pause the video again if you want and try to figure out what the equation of the line is for part C. Okay, I'm going to go ahead and do it. So to find the equation of the line, we need to do 2 things. Number 1, we need to find the slope. And number 2, we need to find the y-intercept. And well, I said 2 things, but the third thing really what we need to do is just write the equation. I'll just say write it. All right, so the slope, if you remember the slope, I'm going to zoom in here. The slope is m equals y2 minus y1 over x2 minus x1. Okay, I'm going to highlight the y's in green up here. And y2 minus y1 means the y value from the second point minus the y value from the first point. So I'm going to go ahead and set that up. So I'm going to say m equals 250 minus 300. Okay, on the bottom then it's the x values, and I'm going to go ahead and highlight the x values in red. And the really important thing here is that since I started with the 250 on top, I have to start with the 14 on the bottom. If I were to switch this around and start with the 10, I'm going to get an answer that's different than what I want. So I'm going to do 14 minus 10 on the bottom. And then I'm going to go ahead and simplify that. Now, I don't know if you noticed, but it said at the end that we need to convert your slope to a decimal. So what we're going to do is we're going to figure out what this slope is in the form of a decimal. So we have 250 minus 300 is negative 50. 14 minus 10 is 4. All right. So we are going to now convert that to a decimal. Well, negative 50 divided by 4, we could go grab a calculator and do that. Negative 50 divided by 4, and it's going to hopefully tell us what it is. It's negative 12.5. So there's our decimal. So it's negative 12.5. So our slope, m, is negative 12.5. All right, we converted it to a decimal because it's going to be easier to use as a decimal, because you have to do some calculating with with numbers, and if it's a fraction, you have to do multiple things, but if it's a decimal, it's just multiplication. All right, second thing we need to do is find the y-intercept. So we're going to take y equals mx plus b, and we're going to plug in that slope we just found, and then we're going to plug in one of these points from up above. And I like the first one, and I'm just going to label those x and y. And so if the y is 300, I'm going to start with 300 down here. I'm going to write my slope that I found, which was negative 12.5. And then in parentheses, I'm going to write the 10 because that's my x value. And then I have plus b. Okay, so now I just need to simplify this, and I will find the y-intercept. So to simplify, to start off with, all I'm doing is multiplying the negative 12.5 by 10. So that's just negative 125. And so I'm going to bring down the 300. And I'm going to bring down the plus b. And then since it's negative 125, I'm going to add 125 to both sides. So I end up with 425 and b on the right-hand side. So my b, or my y-intercept, is 425. Okay, so now all I have to do is take my equation y equals mx plus b and replace my m and my b with what I found. So I'm going to say y equals negative 12.5 x plus 425. Okay? All right, so now for these next two, instead of going to a whole bunch of work to find the y-intercept in part D, I'm just going to remember, hey, I just found the y-intercept. It's 425. So I'm going to say, all right, my y-intercept is 425. And what does that y-intercept mean? Well, it means that the oven was 425 degrees, because y is degrees, right? It was 425 degrees when she turned it off. Okay, so she was baking cookies at 425 degrees, and she turned off the oven, and that was the temperature when she turned it off. Okay, the slope is, well, we just figured out the slope, so I don't have to do any math, so it's negative 12.5. And what does the slope represent in this problem? Well, it's negative, which means that when she turns off the oven, it's no longer going to be heating, so the temperature is going to drop. And what it means, negative 12.5, it means it's going to go down 12.5, that's not 12.5, 12.5 degrees. And the x represents minutes, so it's going to be every minute. So if we wait 1 minute, it went down 12.5 degrees. If we wait 2 minutes, it goes down a total of 25 degrees, and so on and so forth. Okay, so this is probably the most important part after you find your equation. You need to be able to explain what's going on. That's the whole idea of a application problem or a word problem, is it's about something, and so we want to know what those numbers actually mean. All right, so it says calculate the x-intercept of this scenario. What does the x-intercept represent in the real world? All right, so the x-intercept is when y is equal to 0. So I'm going to go ahead and put a y that's 0 in a point. And I'm going to take my equation that I just found, y equals negative 12.5 x plus 425. And I'm going to plug that 0 in. So that 0 is going to go right here. So I have 0 equals negative 12.5 x plus 425. Okay, so now all I have to do is solve for x. So to solve for x, I'm going to start by subtracting 425. So I have negative 425 equals negative 12.5x. And then I'm going to divide by negative 12.5. And gosh, I don't know if I can do that in my head. I probably could if I thought about it a while, and some of you are probably like, oh boy, how do I do that? Well, let's just go over to that calculator. So we're going to do negative 425 divided by negative 12.5. And it should give us an answer, 34. Perfect. See, calculators are great. So x equals 34. So that means this is 34. All right, what does this represent in the real world? Well, this is kind of a trick question on this one, because if we remember, x represents minutes, so it's 34 minutes. And y represents degrees, and it's saying 0 degrees. It's a trick question because when we turn off the oven and the temperature starts to drop, it's not going to go all the way down to 0 degrees unless we're outside in the wintertime, right? It's going to drop down to whatever the temperature of the room in the house is, right? And most houses have a temperature of about 70 degrees. So this is an unrealistic x-intercept because there's no way that the oven is going to get down to 0 degrees. Okay, and I'll show you what that means when we graph this one, because our graph is going to look kind of weird. It's going to be a bit different. Okay, a couple more questions here where we just have to substitute numbers into our equation. It says, what will the temperature of the oven, what will be the temperature of the oven 23 minutes after it has been turned off? Okay, so 23 minutes. Remember, minutes is x, so x equals 23. And if we just take our equation, y equals negative 12.5. Instead of writing x, I'm going to write 23 plus 425. Okay, again, I have a multiplication problem that I can't necessarily do very quickly in my head. So I'm going to go over to the calculator. And we have negative 12.5 times 23. 200. Oh, notice what my calculator did. It wrote the wrong thing. Negative 12.5 times 23. So we got to be careful with this one where we're writing. Okay, there we go. Negative 287.5. Okay, so negative 287.5 is the number that's going to replace this. Okay, and again, this is not the simplest addition. We're taking a negative number and adding a big positive number to it. So let's go back over here and say, let's use the calculator. I wonder if I can do this right here. Negative 287.5 plus 425. Will it allow it? Oh no, doesn't allow me to do that. So here we got to just go negative 287.5 plus 425. 137.5. Well, some of you might be like, wait a minute, how'd that get so small? Negative numbers, right? And positive numbers. When we put them together, it's going to be somewhere less than the positive number for sure. All right, so it's 137.5. Let's see here, where were we? Notability. So y equals 137.5, and y is minutes, right? So it's going to take 137.5 minutes for the oven to drop, or after 20. Wait, no, not minutes. It's degrees. My bad. It's going to be 137.5 degrees after 23 minutes. Still kind of hot. Don't touch it. You'll get burned. Okay. Then it says, part H says, how many minutes will it take until the temperature cools down to 150 degrees? Well, degrees is y, right? So this is 150. And I am going to plug that in for y. So I have 150 equals negative 12.5x plus 425. Okay, so I'm going to start by subtracting 425. I better go to the calculator. 150 minus 425. If you guys don't have this calculator, you should grab it. It's kind of fun. Negative 275. All right, so we're going to go negative 275 here. And then we have negative 12.5x. So I'm going to divide by negative 12.5 now, kind of like I did when I found the y-intercept. Not the y-intercept, the x-intercept. Okay, so I'm going to do negative 275 divided by negative 12.5. I'm going to go over to my calculator. Negative 275 divided by negative 12.5. 22. Perfect. X equals 22. And that is minutes because we're talking about X. Okay, so it's going to take 22 minutes for the oven to get down to a 150 degrees. All right. Okay, so now you need to graph this thing. And so if we go into Desmos to graph this thing, we can do that together here. I'm going to open up Desmos. I'm going to use a browser to do it. So I'm going to, oh, it's already there, so it's popping up for me. Okay, so I'm going to enter my equation. So I'm going to say, I'm not using the keyboard, so it's easier to use the keyboard, so I would do that, but it's y equals negative 12.5x plus 425. And you'll notice I can't see my graph, so I just like to take my hands and like make it so I can see it. Okay, and then so we've got our equation in there. Now let's go back over to Notability because we need to change our parameters. So we need x to be negative 10 to 40, y to be negative 100 to 1,000, and we're going to put in minutes and temperature. All right, so let's see if we can do this without having to go back. Okay, so click on the wrench up there. So we're going to go negative 10 and 40, and then we have negative 100 all the way to 1,000. And we're going to put minutes up here with the x, and we're going to put degrees with the y. Okay, so yours should look exactly like that, and you'll notice that the graph behind the little window here is, we can see the whole thing that we want to see from the y-axis to the x-axis. Okay, and then we want to put those points in there, right? So in the second one, what were the points? It was, let's go back over to Notability. So my points were, we have 10, 300, and 14, 250. All right, so let's go ahead and put those in here. So we have the point 10, comma, 300. Okay, and I'm going to click Label, see how it shows up on my graph there. And then in the second one, I'm going to type 14, comma, oh gosh, what was it, 250? Well, here, we can do this and we'll find out. Is it on the line? Yeah. So it must be the right point because it's on the line. All right, so if I hide now the little keyboard, I can take a screen capture of this, and I can take that screen capture and I can put it in my document in Notability, and we'll be all good. All right, now I mentioned I was going to tell you something about the graph. If you look at this graph, it goes all the way down to 0 degrees, and normally it wouldn't do this. So somewhere around like 30 minutes, what's going to happen to this graph in the real world is it's going to stop where it is, and it's just going to now go horizontal or parallel to the x-axis. Okay, so it's going to go down and it's going to go parallel because it's going to get to that room temperature and it's not going to change anymore. All right, but the time's going to keep going, so that's why it's going to be parallel. All right, I think that should be everything that you need to be able to get this one figured out.